So in this lesson, we're talking about properties of exponents. So as we look at properties of exponents, I'll be referring to the 1.3 activity properties of exponents, and there should be a PDF file there. So if we look at the first one, let's just look at a separate example and kind of go back just a second. Could you tell me what 3 squared really means? And I think everyone knows that 3 squared is 3 times 3. What you may not know is there is an exponent right here that's an imaginary exponent. So any variable, number, anything that does not have an exponent carries along an imaginary 1. So that's 3 to the first power times 3 to the first power. Well, what is 1 plus 1? 1 plus 1 is 2. So the base in this expression is your 3, and the exponent is your 1. So anytime you're multiplying things that have the same base, you will add your exponents. So for instance, if you had x squared times x cubed, the base won't change, but what is 2 plus 3? And that is 5. So let's refer then to our activity. Let's look at number 4. Number 4 has 5 to the 4th power times 5 squared. Are the bases the same? Yes, they are. They're both 5. So because they're both 5, and only because they're both 5, we simply add our exponents. And that's going to simplify to 5 to the 6th power. So you can see on your activity the answer is B. Well, if we move on to number 8, that is a fraction. So number 8 has 6 cubed times 6 to the 4th power over 6 to the 4th power. Well, what you can do is cancel those 6 to the 4th power out if you want, because that's just like, for instance, a 2 over 2, they're the same, so they cancel. 6 to the 4th is the exact same thing whether it's on the top or the bottom. But let's say you don't remember that. So the top of that's going to be 6 to the 7th power, and the bottom of that is going to be 6 to the 4th power. Now that brings us to the properties of exponents when we divide. So are the bases the same? Yes. Both bases are 6. Well, if you add exponents when you multiply, then you subtract exponents when you divide. So where's the biggest one? And that's on the top. So 7 minus 4 is 3. So we have 6 to the 3rd power. And that's how that simplifies. Okay, now we've covered multiplying with the same base and dividing with the same base and the exponent powers. But what about when we have something like this? So if we have a 2 to the 3rd power and we're squaring that entire quantity, that's a little different. Well, remember when we had 2 squared, that's the same as 2 times 2. So whatever you're squaring, you're going to multiply by itself twice. So this is going to expand to look like 2 cubed times 2 cubed. So we have the same base. That means we add the exponent. That's 2 to the 6th power. So if you look at a pattern here, when you have an exponent on the outside of a parentheses, you're going to multiply that. 2 times 3 is 6. If you can't remember that rule, because we oftentimes get those confused when we add or when do we multiply, you can always expand something out. How about 3 to the 4th to the 4th power? Well, that's 3 to the 4th times 3 to the 4th times 3 to the 4th times 3 to the 4th. And when you add all those 4's up, it's 3 to the 16th power. 4 times 4 is 16. So if we look at number 34, that's going to put a lot of these properties together. So on number 34, we have 3b squared times 2b squared all over b to the 4th. And the whole entire thing is squared. Well, let's simplify the numerator first here. Are the bases the same? And yes, both of the b's are the same. Well, when you have your coefficient, you're just going to multiply them. So the top of that fraction is going to turn into 6, and we have multiplication with the same base, so we add the 2's, so 6b to the 4th, all over b to the 4th, which is all quantity squared. So if you will remember, when you had something like, let's say 10 over 5. Now we all know that's 2. But 10 is really 2 times 5. And what happens is the 5's cancel to give you 2. You do all of that when you do the division. So right here, because this is a multiply, same as 2 times 5, we have 6 times b to the 4th over b to the 4th. You could cancel those b to the 4ths right now and know that that was 6 squared. If you forget that, which you might, the canceling is sometimes it's just hard to remember, know that that's 6b to the 4th over b to the 4th times 6b to the 4th over b to the 4th. Now hopefully you remember you could cancel because it's numerator and denominator. But again, let's say you forget. When you multiply fractions, you multiply the top 2 and the bottom 2. So 6 times 6 is 36. b to the 4th times b to the 4th is b to the 8th, all over b to the 8th. Now, when you have a division of an exponent, you subtract. So 8 minus 8 is 0. So that's going to turn into 36 b to the 0 power. Now, what you need to know is anything to a 0 power is 1. You have to remember that forever. Forever and ever is 1. So let's look back. B to the 0 is really just 1. So that's 36. So what would x to the 0 power be? I hope you said 1. And it doesn't matter if you know what x is or not. Because whatever x is, it's being taken to a 0 power, so it's 1. 1,000 to the 0 power? 1. 5,000 to the 0 power? 1. Even if you have x, y, z, quantity to the 0 power, that's 1. And you have to know that. So let's look at number 50. You know what, I don't want to do number 50, I just want to do 47. I'm sorry, I changed my mind on you. 47 has a negative, and then we have 2x negative 4y squared times negative 2x squared y 0 all over negative x to the 4th, y to the negative 3, negative 1. Because we haven't talked about negative exponents yet. So let me switch the slide for a minute and show you something about negative exponents. If I have an x to the negative 1, that is the same thing as 1 over x to the positive 1. And the positive 1 exponent is meaningless, so that's 1 over x. Well, what if I start with, let's say, 2 over y to the negative 3? That is the same thing as 2y to the positive 3. So what you notice is when I move a negative exponent to the other part of the fraction, it switches to positive. So in my first example, the negative 1 was in the numerator, and I flipped it to the denominator, so it went positive. In the second example, the y negative 3 was in the denominator, so when I move it to the numerator, it becomes positive. So another example of this might be 1 over x squared y to the negative 4th. I don't need to do anything with this x squared because it's already positive. But the negative 4 cannot exist. I have to make it positive. And in order to get an exponent from negative to positive, I move it to the other part of the fraction. So the y negative 4 will go to the top and become a y 4th and leave the x squared in the bottom. And now everything is positive, and we've simplified it. That may be something new. Just remember it. Now, I have 2 negative exponents here, but there's a lot of simplifying I can do before I mess with those exponents. For one thing, this y to the 0 power, this piece right here, what is that going to turn into? And I hope you said 1. Since the entire top is just multiplication, there's no adding or subtracting, that 1 is meaningless. Now what's 2 times negative 2? That's a negative 4, and I'm just going to carry that negative out front along with me for a minute. X to the negative 4th times x squared. Okay, so, excuse that telephone. 2 times negative 2 is negative 4, and the negative in front, I'm just going to carry it right along. Now I'm looking at my x's, so I have a negative 4 plus 2, because that's the same base. So that's going to turn into a negative 2. Now this y over here doesn't matter anymore, but even if you forget that that's a 1, you have a y2 and a y0. 2 plus 0 is 2. So it stays a 2. Now let's look at the denominator of this. That's the whole piece times negative 1. How would I make that 1 positive? It's in the denominator now, so if I move the whole piece to the top, then that would be positive. Okay, so now I have nothing left in my denominator because I brought the whole piece. Now it's still multiplication. So let's just look at the negative out front. The negative times the negative 4, those would turn positive. And I have x negative 2 times negative x4. So that's going to give me a negative, and I'm going to put that negative out front because that's where they go. Negative 2 plus 4 is x squared. And then a y squared times a y negative 3 is a y negative 1. And then that's going to simplify, because I can't have that negative 1, to negative 4x squared over y. So if you look at your answers, that is choice A. You have to just be very careful when you're doing these positive and negative exponents. But other than that, I think you can get this one. Take your time, be very tedious, and good luck.